Hello everyone. In this video we're going to take a look at 3-axis machining using VisualCAMc, the full cloud production CAM solution for Onshape. Okay, so I got my VisualCAMc tab displayed, and let's take a look at the Onshape part that we're going to machine. And we'll go back over to our VisualCAMc tab, and we're going to load our part model. And let's go ahead, and there's our part model. And let's start out with a roughing operation. We'll go to 3.5 axis. Well, before that, let's go ahead and do our setup. Our machine set to 3 axis. For the post, we'll select our Haas controller. For the stock, we'll do a part box stock, and we'll add a little bit of material on the top face. And our setup is aligned in the direction that we want to machine. Okay, so let's go ahead and create our work 0. We'll set it to the stock box, highest face, and in the center. Okay, to start off, we're going to do a facing operation on the top of the part. So we'll go ahead and open our facing. We already had one there. We'll open our facing operation. Let's get rid of that selection, and let's select the top of our part. And for the tool, we'll go ahead and create a face mill tool for that. And we'll make a face mill of 2 inches. And that should be fine. Save that. And for our parameters, we're going to use a tolerance and a stock. We'll set the stock to 0. We'll do an offset cut pattern. 25% is fine. Our location of cut geometry is at the bottom. We're going to cut down to this level, and we're going to do it in one level. So let's go ahead and do our entry and exit. Lines and arcs, and we'll do some arc fitting. Let's generate. So here is our facing operation on the top of our cavity block. So let's go ahead and do some roughing inside this cavity area. So we'll go to 3 axis, Z level roughing, and we'll select our 1/2 inch end mill. Feeds and speeds, we'll leave those set to default. Clearance plane is set to the default. For the parameters for roughing, we want to rough it. I'm going to use a tighter tolerance for roughing. We'll leave 25 thousandths of stock. We'll do an offset cut pattern, and we'll do a cleanup pass. Everything else looks good. For the distance for the cut levels, we'll leave that at 1/8 of an inch. And entry and exit, we'll use a helical motion. And for the cut arc fitting, and let's generate. So here is our roughing. Looks like we didn't get a whole lot of material out. Let's go ahead and use a smaller tool on that. Let's change that tool to a 1/4 inch tool. And we'll call this flat mill 1/4 inch. Save that. And everything else should be the same. Let's go ahead and rerun that. Okay, so that's a little bit better. We got some nice roughing material taken out of there. We might want to adjust the step down just a little bit. Let's make that 6. Okay, so we got our roughing operation. Let's go ahead and do some finishing. Let's turn the toolpaths off for now. We'll do some finishing on this bottom area here. So we're going to do some 3-axis, and we'll do a radial. Let's do a spiral machining, and we'll leave that selected, but we're also going to select this bottom edge around the bottom. So we're going to spiral from this area all the way up. And let's create a new tool. Use a ball mill this time. Let's try a 1/16 ball. Save that. And for the parameters, 1,000 in tolerance, 1,000 out tolerance. The stock will be 0, will be right on the part. And we'll start on the outside and work our way down. And we don't need a minimum radius because we've got an inner diameter containment selected. For the offset distance, let's make it 0.5 and see how that looks. We don't need any Z containment. And we don't, for the engagement, we'll leave it as radial engagement and radial exit. Let's generate that. Okay, so we look like we got a pretty wide spiral, so we can tighten that up a little bit. And let's do a step over of 5 thousandths and see how that looks. Okay, so that's a little bit better. We got some nice step over down in here. If you want to, you can create another operation to clean this up a little bit up at the top. Let's go ahead and do that. For that operation, we'll do a Z level finishing on the sidewalls. That's a, it'll finish in levels, in horizontal levels. So let's deselect our selections and let's select from here to here. And we'll use the same 16th ball mill. And we'll go ahead and have a cut distance of 5 thousandths. And that all looks good. We'll do a lines and arcs. I would do a arc fitting. Let's generate that. So we got a horizontal finish on this outer wall here, and let's go ahead and do a some finishing on this inner cavity region. So let's go ahead and we'll start with a spiral, and we'll deselect our selections and we'll spiral all the way around this area. And let's go ahead and select the tool for our 16th ball mill. Tolerances will look good, and we'll start on the inside. And in this case, we'll leave the minimum radius at 0. We'll just start right in the center, and we'll come back and we'll do a facing operation on that little area. Let's do a step over 5 thousandths and no Z containment, entry and exit. I have a radial, and let's generate that and see what it looks like. Okay, so there's our nice spiral toolpath, and let's looks like we're not starting in the center, so let's go ahead and change that and do a start center point. And there it is. Let's specify the center point, and we'll just have the center point at 0, and let's regenerate that again. Okay, so we got our center point, start point, our engagement area, and we're going to spiral all the way out to the outside area in our radial retract. So that's a nice spiral motion. Let's go ahead and do couple this with a radial motion just in these fan blade areas. So let's go ahead and turn that off. And we'll go ahead and select 3-axis. We'll do radial. We'll clear our geometry selections, and let's select around this area. So we're going to work our way around here. Okay, so we got our perimeter selected for our radial machining. Let's go ahead and use the same ball mill, same feeds and speeds, same clearance. And for our parameters, tolerance is 1000, stock is 0. And we're going to do a zigzag climb pattern. And this time we'll start on the inside and go to the outside. And we'll leave the center point at 0 again, and we'll do a nice fine step over. And let's generate that. Okay, so let's take a look at that toolpath. We got a nice radial motion starting at the center and doing radius outwards all the way around each of those fan blade areas. So let's take a look at what we've got. We've got a facing on the top. We've got a Z-level roughing. We got a spiral machining, a Z-level finishing, a spiral machining, and a radial machining. Let's go ahead and do a facing operation just on this center area, just to flatten that off. So we'll do 2.5-axis facing, and we'll deselect our areas, and we'll select this area here. And for the tool, let's go ahead and create a smaller flat mill, maybe a 1/8 inch. And we'll save that. And for the parameters, our tolerance, we'll set that to 1/1000. Stock will be 0. We'll do an offset cut pattern. And for a step over 06, our location of cut geometry is at the bottom, so our depth's going to be at 0 depth, so it's going to cut 1 level right on that area right there. And for the entry and exit, we can go ahead and do lines and arcs should be fine there. And let's do a ramp motion so we don't stay away from this finished area on the end here. Okay, so for the exit, we'll do none. For advanced, we'll do arc fitting, and let's do some cut rounding. Let's see how that looks. So we have a nice little facing operation on the top of that part to clear that off.